And we're here today to talk about our new branch gateway set of capabilities. We felt it important to first baseline on some key architectural components, namely how our sites deployed in the past, and then we'll kind of pivot into how we can change architecture in the future. So as a quick baseline, there's really two site types that we have previous to our releases this summer. One was data center mode. And some key functions of data center mode were as follows. You have really high VPN scale and throughput, supporting as many as 1,500 to 2,000 branch sites per cluster. And then we have scale out capabilities as well to scale out to tens of thousands of branch sites. Data center nodes actually also act as a link quality monitoring server. So that allows branches to act as clients to go and test their link quality across all the various circuits and transports from the branch to the data center and get an always-on measurement of latency loss, jitter, MOS score, so on and so forth. They also automatically form VPNs to every branch in the entire tenant. They serve as a hub for branch-to-branch traffic. They can also be used in traffic engineering as a policy transit location to send traffic to a data center as perhaps a transit to somewhere else that may be unknown to the branch. So any unknown enterprise or public traffic can be sent to a data center for further forwarding. And lastly, they act in an active-active HA manner. So those are all key tenets of data center mode. Branch mode. So branch mode, I think one of the obvious things is that the branch mode is policy driven. So you have very granular policy control for path selection, zone-based firewall and security enforcement, performance policy, quality of service, NAT behaviors. So very, very granular control with out-of-the-box intelligent defaults. Next is one of the core foundational components of Prisma SDWAN, which is the application performance visibility. So it includes for both TCP applications and SaaS, as well as real-time media applications, Zoom, RTP, so on and so forth. So all that goodness of application visibility, which gets rolled into path selection as well, is a key function of the branch. The branch is also a link quality monitoring client. So it generates the request that says, hey, on the MPLS path, on this set of VPNs to my data center, what's the latency loss, jitter, MOS score, and health score on those paths, and exports that data every minute around the clock. And it's always there available for path selection and visibility purposes. The other key part of a branch is that it has, leveraging our HA model and our fail-to-wire capabilities, we can actually preserve circuit capacity during a unit failover so that you don't have to have any type of breakout switches and you can still, to keep those circuits available, you leverage the fail-to-wire capabilities in the ION 1200S and above platforms to do that. Branches also support direct internet traffic vectors so that you can take traffic and put it directly on the internet while leveraging intelligent traffic monitoring to make sure that that application is actually successful on that particular path using app reachability and other RTT measurements using performance policy to set your SLAs there. And then lastly, a branch will also form a VPN to every single data center in the environment. Now, that brings us to the topic of today, which is branch gateway mode, which is really a new operating mode that we've introduced this summer. And if you think about three key areas that we're introducing here, right, that we're bringing things together. So branch gateway is simply a mode that you put a branch into that gives it a lot of the same capabilities as a hub and all the same capabilities as a branch. So the first one is through the area of topology. So once you have a branch there defined, it gets put into a domain, which is a required attribute. Domains are typically organized in a geographical manner. US East, Asia Pac, Europe, you name it. It's up to you as a customer on how you organize that. Once you turn a branch into a branch gateway mode with the one-click integration, the one-click setting, that branch gateway then becomes a regional hub and forms a VPN to every single other branch in that domain. You can alternatively form manual VPNs to other locations outside of that domain if you wish, but the automatic portion is for branches in the same domain as the branch gateway. Additionally, a branch gateway node or site can also be a transit location in the service and DC group selection. And that's used in path policy, just like you would set a data center or Prisma Access as a transit location, you can now set a branch gateway site as a transit location. And then WAN-to-WAN forwarding is allowed. So you have things like where you can have connections coming in from a remote branch all over a Fabric VPN and then being sent to Prisma Access directly on the internet, of course, to the LAN side of a branch gateway or into an MPLS underlay, for example. But that WAN-to-WAN vector is supported, and we have additional visibility that helps you understand the exact traffic paths. Second piece is visibility. So all of that same goodness and really industry-leading application visibility that we have in branch mode is there for branch gateway mode as well. And that includes flow browser, app stats, real-time media, everything across the board is there, and including our new probe service capabilities. Around link quality. So the branch gateway can be either a link quality monitoring server. So for every branch that it connects to via VPN, it will be a link quality monitoring server. So it generates that server capability just like a data center would. It can also be a link quality monitoring client if it is connecting to another branch gateway or a data center. So we kind of include any combination of things, and this is all dynamically. So it's on a per secure fabric link basis. That capability is there, and they're basically negotiated when you have another branch, when you have a branch to branch gateway tunnel or a branch gateway to DC tunnel. And last is policy. So all of that, very granular control over paths, security, performance, QoS, all those things from a policy control perspective are there just like for the branch mode here in branch gateway. Now, there is one interesting thing, and that we know that there's some customers that maybe quite a few that may want to convert their existing data centers to branch gateways. And but they don't want to change how traffic's forwarded necessarily. You just maybe want to get the additional visibility components of a branch gateway, but want to keep the same traffic vector coming in, where you might have a branch sending traffic to a branch gateway that then comes into a data center core and then goes out through an NGFW from there. And so we actually offer two different operating modes that will enable that. The default is, if the traffic's destined to the internet, it'll actually go whatever path you've specified in policy. Or you can set the branch gateway to prefer the LAN side, and that'll make it act just like a data center mode deployment, so that traffic will come in from the WAN and go into the core peer in that case. And at the end of the day, we've really taken all the best pieces and parts of both operating modes and brought them together into the branch gateway capability. Now, Sunil will get much more in depth in these in the coming rest of the hour as far as use cases go. A few are just mentioned here. Regional data centers, layer 3 data center interconnect that's SD-WAN enabled are just some of the use cases. Benefits, we talked about those already. From a support perspective, this does require software image 641 or higher. And then from an actual platform perspective, we support it on every place you can run data center mode today. We support this for branch gateway. So it basically includes ION 3000 and up, all the way to 9200, with the note that the 3000, 7000 are end of sale. In addition to all of the vION models are supported for branch gateway mode. And with that, I'll turn you over to my distinguished colleague, Sunil Cherukuri, for a technical deep dive on branch gateway. Sunil, over to you.
Thanks, Bill. I'm just going to share my screen. Can you guys hear me okay?
Yes, sir.
Okay, so Bill introduced the branch gateway. Let's first talk about some of the common use cases where the branch gateway can help with your deployment scenarios. So the way this next section is structured is we will show you how DC deployment is done today, and some scenarios where the DC mode may not solve all the requirements for the customer and how, if we instead deploy a branch gateway, how it can help in these scenarios. So the first scenario, let's talk about the DC. So typically the data center sites are hosting applications, right? So we deploy an Ion appliance as a hub in the DC mode, and for serving application access into the data center. But oftentimes we see customers might have smaller data centers where they not only are hosting applications, but they also have users sitting. So it could be a small office where they host certain applications and there are users sitting in there. So as Bill mentioned before, in the DC mode, we do not have zone-based firewall, NAT, and path policy, such functionality. So in this case, till recently, in these scenarios, you would deploy a pair of ions in the data center mode to connect all the other remaining branches to have access to the applications inside the data center. Now, for the user sitting inside the data center, for them to go out to the internet or to other locations, we need SD-WAN functionality, we need NAT firewall functionality. So in that case, we deploy a second pair of ions here so that the user traffic coming in from the users will be sent to the branch mode ions and get all the policy and firewall and NAT functionality and go out to wherever it needs to go out to. So that's how we had it for if you're deploying with the DC mode. Now, instead of deploying four ion devices, you can simply deploy two ions in a branch gateway mode. So you'll just have one pair of ions collapse, the four ions collapse into two ions in the branch gateway mode, and you'll be able to service your other branches accessing applications and also the users going out to the internet or any other location with SD-WAN and path policy and zone-based firewall and NAT functionality. So that's one key use case where the branch gateway helps a lot. Let's talk about another scenario where if you had two data centers and a deployed ions in the DC mode, if you wanted to have DCI kind of capability, today you can do that with the standard VPN tunnels where we build an IPsec tunnel. Again, this is not an SD-WAN VPN tunnel, but this is a standard IPsec tunnel. And because there is no SDN-based prefix exchange, you will require to run BGP through the tunnel. And the tunnel config itself is not automated. So only the Fabric VPN tunnels are automatically programmed and brought up. For standard VPN, you have to manually configure the tunnels. So in this scenario, instead of deploying the ions in the DC mode, if you deploy them in the branch gateway mode on both sides, then you can automatically bring up tunnels. You can bring up SD-WAN tunnels between the branch gateways. And there is no need to run BGP because the controller will do the prefix exchange between the two branch gateways. So this is another scenario where branch gateway mode will help, instead of using a DC mode. And again, this common use case is today, if you deploy the ion in a DC mode, you do not get any metrics or visibility from the DC point of view. You will get it from the branch point of view, but not from the DC point of view. So oftentimes there might be some DC initiated flows, for example, data center replication backups and such, where you might want to get visibility from the DC point of view. In this scenario, instead of for DC mode, you deploy the branch gateway mode, and then you get the visibility for all your traffic from inbound and outbound. Another scenario we see, this is not very common, but like Bill was showing before, in the branch mode, we have the fail-to-wire capability. In the DC mode, the two DC ions are discrete devices. There is no fail-to-wire functionality. They are individual. It's an active-active deployment. So each ion will have its own IP address for each circuit. So you would need to have an L2 switch in front of the ions so that you can present the same circuit to both the ions. This may not be an issue in a typical enterprise scenario where there might be an L2 switch or maybe reuse the LAN switch on the WAN side. But in a managed service provider kind of scenarios, this might be an issue because there might not be a managed L2 switch that the MSP may want to use. So in this case, in such scenarios, instead of the DC mode, you can deploy the branch gateway mode. And because the branch gateway is deployed physically, topologically exactly like a branch mode, you can make use, it's an active standby deployment. You can make use of the fail to wire, and the circuit needs to be connected directly to only one ion, and then you can fail to wire over to the backup ion. So in these scenarios, the branch gateway mode will be very helpful. Another scenario is, let's say a data center, you have deployed your ions in the DC mode till date. So you might have applications sitting in the data center which might need to go out to the internet. So for example, applications might need to get a Microsoft update or virus AV updates and such. So in these scenarios, the DC ion would not be able to handle that outbound traffic because there is no NAT functionality or firewall functionality on the DC mode ion. So in these cases, you have to deploy an NG firewall so that the applications can go out to the internet. Now, in the same scenario, instead of the DC mode, if we deploy the branch gateway mode, then we can handle outbound traffic. We get the SD-WAN, path selection, zone-based firewall, NAT functionality and so forth. So that's another scenario where the branch gateway will help. Similarly, on the same note, some customers may deploy their DC to be centralized access point for internet transit from the branches. So in this case, you want your branches, instead of going DIA to the internet, you might want to bring the traffic on a VPN tunnel to the DC and then go out to the internet. So if you deploy the ions in the DC mode here, in the DC mode, again, as I mentioned, we cannot hairpin the traffic. So the traffic coming from the branch cannot be sent back hairpin out to the internet this way, because again, we don't have the zone-based firewall capability. So you are forced to use an NG firewall for that scenario. And in the same scenario, instead of the DC mode ions, you can deploy the branch gateway here, and then you don't need an extra firewall. You can hairpin traffic coming from the other branches, come into the branch gateway as transit, and can be hairpin back outbound to the internet. Similar notes, another scenario we often encounter is as the SD-WAN, Prisma SD-WAN is rolled out. Let's say you might have 200 sites, maybe only 100 sites have been cut over to SD-WAN, but there's still some legacy sites, or maybe there are other connectivity from some legacy provider. So let's say you have this, at the bottom, you have the SD-WAN branches, and at the top, you have deployed the DC mode ions. And then you have legacy sites connected through some legacy provider into the DC. And in this case, you might have overlapping address space, and you want to provide some NAT functionality, or you want to secure which subnet on the legacy side you can talk to, which subnet on the branch side and such. So you have to use a firewall for that purpose. Now, same thing, instead of the DC mode, if you deploy the branch gateway mode, you can collapse this two-box solution into a single box with the ion. And finally, I think it will also help in geo or regional data center kind of scenarios. So for example, some customers may have requirements that branches in certain countries may need to talk to, need to transit through a data center or hub in country and not go out to a hub in a different country. Have a global deployment, you are okay for all the branches to bring tunnels to all the DCs in Europe and Asia, but maybe you do not want the branches in Europe and Asia, Europe and US to build tunnels to China data center, for example. So prior to the summer, that was not possible because the branches will automatically build tunnels to every other DC in the deployment. Right. So the solution for this so far was you had to go and admin down manually the tunnels that you do not want to have established. So for example, from US to China, you bring down the tunnels. Now, the same scenario can be simplified by using the branch gateway, because in the branch gateway, like Bill mentioned, branches in the domain will automatically build tunnels only to branch gateway in the same domain. So let's look at that from a different diagram point of view. So in your deployment, you can have X number of branches in the domain US, and then you have a branch gateway with the domain US. So these branches will automatically build tunnels only to this branch gateway. Similarly, your EU branches, because they're in the EU domain, will automatically build tunnels only to the EU branch gateway. That's shown by this red line here. Same thing for APAC, right? Now, this way, you're controlling that the traffic going from the US branches will always go to the US branch gateway before they transit anywhere else. Now, for the US branch to talk to the EU branch, you have two options. One is you can build a tunnel between these two branch gateways and then have that to be a connectivity point, kind of like a DCI scenario. Or you could optionally also build a hierarchical deployment and deploy a DC mode on top, so that any traffic patterns between US branch gateway and EU branch gateway will have to transit to this DC mode. So you have the option of either doing interconnect between the branch gateways directly or through a data center node deployed at the higher level. Let's look into the configurations now for the branch gateway. Like Bill mentioned, it's a very simple one-click option. So when you're deploying a new site, you deploy it as a branch site, and then you have a knob here saying, is this a normal branch or is it a branch gateway? So it's just a single knob to say, define that this is going to be a branch gateway deployment. Now, if you already have a branch site deployed, you can convert it into a branch gateway again by simply, when you go to the site configuration screen, you have an option to convert this into a branch gateway. And once you convert that, you can also see in the CLI, you would see that the branch gateway functionality is enabled. One key thing to remember is the branch gateway functionality is only supported if the ION has been set up to have L3 LAN and L3 WAN forwarding. Again, these are config elements in the device level configuration page. You have a second way of converting a branch site into a branch gateway. Actually, sorry, before going that, when you go and say, yeah, you already have an existing branch site, you want to convert it into a branch gateway, you simply enable this knob. And when you do that, you get a pop-up screen. And then there are certain config knobs you have. And again, I'll talk about them in the next few slides. But you select, optionally, you can select these options here. And again, I'll talk about them in a few slides. You also can do the conversion from the branch site list. So if you have the list of branch sites, you can go into the three-dot ellipsis on the right side of the branch site and say switch to branch gateway site. So there are two ways to do this, either from the branch site page or the branch site configuration page. Now, to support this functionality, we have also expanded the overlay connections page so that we now can categorize and show the tunnels. So you have the branch gateway to DC tunnels shown up if you click on this tab. You have the branch gateway to standard VPN tunnels shown up in this tab, branch gateway to branch tunnels shown up in this tab, and branch gateway to branch gateway shown up in this tab. So we have expanded this page to show the different VPN options you have. So like Bill mentioned, branch to branch gateway is automatic in the same domain. Branch gateway to DC tunnels are also automatic. But if you want to build branch gateway to another branch gateway or a branch in domain US to a branch gateway in the Europe domain, then you have a single click to do a manual VPN creation. So it's not automatic. When you've converted, I mentioned there's a knob here which says how many maximum branch site you can connect. So this is an optional knob, and again, it's a soft limit. So you might want to say that, hey, I'm deploying a branch gateway in the US, and I do not want more than 50 branch. I mean, you can configure 50, let's say 50 as a limit. So it's a soft limit. So 50 branches will connect automatically into the branch gateway. When the 51st branch comes in, we won't stop the VPN from establishing, but we will raise the threshold because you as a user have said that, hey, I want to be notified when more than 50 branches are connecting to this branch gateway. So this is a way for you to limit the number of tunnels to be brought up on the branch gateway site. Another enhancement we have is because the branch gateway can do WAN-to-WAN forwarding, it acts as a transit for other branches to talk to each other or to go to the internet or elsewhere. We now show both for a flow, we show the ingress path and the egress path. So basically, if branch 1 is talking to branch 2 through the branch gateway, we will show that, hey, it came in on the VPN on the internet. Then we will send it out on the VPN on MPLS, for example. So we'll show you both the ingress and egress path. Let's look at a few prefix distribution details here. As you are aware, in Prisma SD-WAN, the prefix distribution is all done through the controller. So it's an SDN prefix distribution. So let's look at a scenario where you have branches at the bottom, you have a branch gateway, and let's say you also have a DC here. So the 10.1 at branch 1 and 10.2 at branch 2 are sent, the ION will send it out to the controller, and the controller will distribute that to the branch gateway and to the DC. Now, if you see here, when the controller distributes this to branch gateway here, it says hop count equal to 1 because this 10.1.10.1.0.0 is reachable via direct tunnel on branch gateway. Now, when the same 10.1.0.0 is sent by the controller towards the data center node here, it will say that hop count is equal to 2. So basically, that's because the 10.1 is not directly reachable through the DC ion. It's actually reachable through one hop away, 2 hops away, essentially. So 2 tunnels, right? So this hop count is something we introduced new, and I'll explain why that matters. So prior to this functionality, the controller would only distribute prefixes with hop count 1 to all the other ions in the fabric. So essentially, each ion would know what is directly connected through a tunnel from the other ions. With the branch gateway functionality in 641, we will distribute hop count 1 and hop count 2. Why not more than 2 is because we do not want to have loops in the network. So it's a kind of loop avoidance where we restrict it to hop count 1 and 2. And a key thing to remember here is the prefix 10.1 that's coming from the branch is learned from the branch here. The controller will distribute that to branch gateway and to the data center. Now, whatever prefix is learned at the branch gateway, this 11.100, is sent by the controller to both the DC and to the branches. Now, the prefix, let's say the DC itself has a prefix 12.100. That prefix is sent by the controller to the branch gateway, but it will not send those prefixes to the branches. And this is not an issue because the branch will always have a default path on its tunnels, so that if any unknown prefixes, it will always try to send based on the path policy and the service and DC groups. It can send it either to the branch gateway or to the data center directly, right? So key here is that anything learned from a branch to a branch gateway will also be sent to the DC, but anything from the DC in this kind of hierarchical design would be sent to the branch gateway, but not to the branches. Now let's look at when you introduce routing protocols into the mix, let's say BGP here. Let's see how the BGP learned prefixes get distributed. So let's say the branch gateway has 10.100 on the LAN side, and that's learned via BGP on the ION branch gateway mode. So this 10.100 is sent on the BGP towards the MPLS network on the underlay. It is sent via SDN distribution by the controller towards the other branches or other data centers. And it's also sent, for example, if you have legacy firewall site with a firewall or a router, it's with BGP, it's sent over on this path also. Now, when you have whatever routes we learn from the MPLS on the underlay via BGP here, will not be sent to the fabric or to the standard VPN. Now, let's say the branch has 11.100. That is distributed by the SDN controller towards the branch gateway on this fabric VPN tunnel, and that's also distributed into the via BGP into the branch, and also sent on the BGP over to the standard VPN tunnel to the legacy site. So one enhancement we have with the branch gateway functionality is the 12.100, which is the prefix on the legacy side, which we're learning via BGP on the standard VPN tunnel. That we will be sent into the BGP on the LAN side as before. And what is new here is that will also be sent by the SDN controller towards the other branches. So basically, this 12.1 will also be distributed, which is learned by BGP here on this branch gateway, will be distributed by the controller into the other branches. So that's something new from a branch gateway functionality point of view. This is a reference slide to say how we distribute the BGP learned prefixes and where they're sent to. Now let's look at the path policies and the service and DC groups. So if you remember, we have the service and DC group construct where you can define, so, if you have multiple DCs, you can define them in DC groups as an active DC group and backup DC group. And based on the domain, the path policy for a branch gets evaluated, and you can influence that, hey, the branches in US domain will first prefer the US data center and the backup would be Europe data center. So same concept can be applied to the branch gateway also, because we have, when you do the service and DC groups, you can define data centers or branch gateways here. And when you create the path policy, whatever service and DC group you created with the DC and branch gateway can be applied here. The key thing to remember is that when you apply a path policy to the branch gateway itself, just make sure that you apply the path policy to a branch gateway just like any other branch, but make sure that whatever policy applying to branch gateway 1 should not refer to itself in the service and DC group as the preferred transit point of view. When you have LAN to WAN forwarding, the path selection for a branch gateway works exactly like a branch mode. There's no difference. Now, when it comes to WAN forwarding, which is a new functionality for a branch gateway, the policies are applied only on the egress path. So any locally initiated flows from the branch gateway's point of view will have the path policy applied. Now, if we had any ingress flow coming in from another branch into the branch gateway, the return packet will be sent back on the same path the ingress packet came in on. So essentially, there's no path selection per se. We basically, the other side already did a path selection, send it on VPN one, and the branch gateway will send the return packet back on VPN one. So this is similar behavior as the data center mode. Let's talk about a few configuration knobs that we have for certain scenarios. So let's talk about a scenario where you have the centralized internet access through the branch gateway, for example. So you want the branches to send traffic to on the VPN tunnel to branch gateway, and then send out to the internet. Now you have two options here. One is the traffic coming in from the branch or to the branch gateway can be hairpinned out and sent back to the internet by making use of the zone-based firewall functionality and the NAT functionality on the branch gateway. Or alternately, you can bring the traffic in on the VPN onto the branch gateway, send it to the LAN side, and then send it to a NG firewall, maybe because you want to get the additional NG firewall capabilities on the NG firewall and go to the internet. Now, the issue here is on the WAN interface of the branch gateway, you have a default gateway. So basically, you have a default route on the WAN interface, and you might have a default gateway or a static default route on the LAN side. So in this case, how do you control which way, do you want to hairpin the traffic out or go on the LAN side to another NG firewall and go out? So for this, we have a config knob, which says, so basically by default, any unknown prefix, so basically internet bound traffic, will prefer to go on the WAN. So the WAN to WAN forwarding will be the default mode. However, if you want to prefer the traffic to go on the LAN side, the branch gateway should send the traffic to the LAN and then go to an NG firewall. When you do the site configuration, you have a knob saying prefer LAN default over WAN. So if that's what you want to intend to do, you just enable this knob. Another scenario is similarly when you were trying to do centralized internet access, for example, through a branch gateway, and let's say you have a set of sites converted into SD-WAN, but maybe you already have legacy sites still existing, and let's say you want to have the internet-bound traffic from the legacy site, bring that on the MPLS underlay, for example, and then come into the branch gateway, and then you want to send to the internet. To do this, we need to advertise a default route into the MPLS underlay. We didn't have this functionality prior to this, but with now we have this introduced this knob here. On a per peer basis, you can say that, hey, on this peer, advertise a default route. So use case would be that when you do BGP peering towards the MPLS router, you can enable the knob so that you can send a default route and attract internet bound traffic from legacy sites into the branch gateway. Another scenario that we can talk about here is, let's say we talk about cloud deployments. You're deploying the branch gateway in the cloud, and you might be doing BGP on a standard VPN tunnel towards a transit gateway in AWS or a cloud router in a GCP or such. So if you were deploying the DC mode prior to the branch gateway functionality, you would have to configure all the application VPC subnets as site prefixes at the DC site level, and those will be advertised into the fabric. With the branch gateway functionality, we made this simpler so that you don't actually have to manually configure the site prefixes at the like we need to for the DC site. Instead, whatever BGP routes prefixes we're learning from the transit gateway on the SAN VPN tunnel will be sent on the VPN SD-WAN fabric by the controller into the other branches. So we made this simpler for you so that instead of you configuring the VPC subnets, we can automatically learn and then send them out to the branches. Now, we also intend to bring the same functionality for the DC mode in the subsequent release coming to the end of the year. Okay, so let's wrap this up. So just to kind of say what are the key takeaways from this session. So up to the summer, we had two modes of operation for a site, either the branch mode or the data center mode. With the 6.4.1 release, we have a new branch gateway mode of operation, which provides you architectural flexibility in how you want to deploy Prisma SD-WAN in the deployment. So think of the branch gateway as a mix or the best of both the branch and DC mode. So you have, the hub kind of functionality for the DC from the DC side, and you also have the path selection, SD-WAN functionality, all the path policies, NAT, zone-based firewall, and such of the branch available in the branch gateway. So essentially, this helps you in the scenarios or use cases where you want to have a native DCI mechanism in the fabric with all full SD-WAN functionality, and you do not need to use standard VPN tunnels and run BGP through them. It will also help with the hybrid data center scenarios where you're hosting applications and users in the data center, and you want to, service both through just a single pair of Ion devices. And when you're deploying Ions in a data center, if you deploy them as a branch gateway, you get the full visibility from a data center perspective for DC initiated flows or inbound flows. And you get all the policies, the NAT, zone-based firewall, path, performance, QoS policies applicable for a branch gateway. And it will also help you in the geo-regional or hierarchical deployments, where you can layer branch gateways and certain regionalized branch gateways to certain set of branches, and additionally, you can deploy data center mode on top for a hierarchical design. With that, we come to the end of the session. We can open this up for Q&A.